What we're going to take a look at here is factoring quadratic expressions when we have an a value that is greater than 1. Everything that we have done so far has had an a value that's equal to 1, but now when we have an a value that's greater than 1, we're going to have a little bit of some tweaks in the process for how we're going to go about factoring these expressions. So, for example, we may get something like factor 2x squared minus x minus 6. Now, we're going to go through a lot of the same four-step process that we had done before. So the first thing that we've done is, and no matter what, you should always look for some kind of greatest common factor first, or some GCF, something that is shared throughout every term here. And if I look at all three of these, 2, negative 1, negative 6, nothing is shared, and there's not an x term to be shared amongst all three of these terms. So 2x squared minus x minus 6, there's no GCF that we can remove. So we can move on to step 2. Now, we're going to go through our x method, and if we take a look at it, everything that we have done so far has had b on the top and a times c on the bottom. Now, for the most part, we've had a values that have been 1, so it's really only been b on the top and c on the bottom, but now what we look at is we're going to have an a value that is not 1, so we're going to have to actually incorporate that down here. So on the top will still be negative 1, on the bottom a times c will give us negative 12. So now I'm going to look and I'm going to say, alright, let me find two numbers that add to this top number and multiply to this bottom number, just like we had done in the past. To do that, we're going to need our multiplication table. So we're looking for two numbers that add to negative 1, multiply to negative 12. If I look at that, I'm going to look to see, alright, well, what multiplies to 12 or negative 12? Here's a 12, here's a 12, here's a 12, here's a 12, and then on the bottom over here, and I can't really see it, but over here, down here as well. And if I look across this now, I'm looking to see, for it to be negative, one of the numbers has to be negative. For negative times a positive will give us the negative number. That's what we're looking for. I'm looking to see, all right, what two of these number pairs, if one of them is going to be negative, will give us that negative 1 as a sum. And what that ends up being, if I look at all of these number pairs, I could write them all out. If I look, I have 12 and negative 1, or negative 12 and 1. If I look, I also have 6 and negative 2, and then negative 2, and then negative 6 and 2, or I could have 4 and negative 3, negative 4, and positive 3. So looking across all of these numbers, the only one that gives us a sum of negative 1 would be negative 4 and positive 3. So those are going to end up being our two factors, which would be written here and here. And again, this is not different than anything that we have done so far. The only thing that was different is that when we multiplied a times c, we had an a value that was not 1. That's the only thing that's been different so far. Now, this is again the same exact step. We're going to write this out with the factors that we just got, being negative 4 and 3, with the same coefficient as x squared. So in the past we had just done, we only had an x squared with 1 here. Now when I actually write my binomials, I'm going to have 2x minus 4 and 2x minus 3. Okay, because my a value here is 2, I'm always going to do this. In the past it was just we had an a value of 1, that's why we wrote 1 and 1 as the coefficients in front of the x term. Now we write 2 because that's the a value that we had. Okay, which again is not anything super different than what we have done. It's just now we're actually incorporating that a value. Last but not least, get rid of the GCF, greatest common factor, from each factor if necessary. So from here, what we are going to do is we're going to look at each binomial. So I'm going to look at 2x minus 4, and then I'm going to look at 2x minus 3, and I'm going to look to see if there's a GCF. So if there's some number that I can divide from both this number and this number. Same thing over here, from the 2 and the negative 3. If I look at the left-hand side, there's no GCF. There's nothing that I can divide out from 2 and from 3. But on this left binomial there is. If I look at the 2 and the 4, I could divide each of these by 2. And if I go through and I actually do that, I would end up with x minus 2. If I divide each of these terms by 2. This right-hand binomial, there's nothing that I could divide out. No GCF here. And that's really the last step what I'm going to do for this factoring. Now, this is something that we always have to keep in mind when we're factoring something with an a value that's greater than 1. Always. Okay, there's always going to be something that we're going to be able to remove back out at the end. And if you notice, this is the same as the a value that we started with. Okay, the GCF here was 1, GCF here is 2. Those two multiplied together ended up giving us our a value from the beginning, which makes a little bit of sense because from our x, this a times c, there's really, no reason for us being allowed to do that. So we multiplied by the a. Now we have to actually kind of come back and divide the a back out. And that's what we did by pulling out this 2 here. But all in all, the factored form of 2x squared minus x minus 6 would be this. And if I wanted to check that, I could. I could go through and I could FOIL, multiply the first, outside, inside, and last terms, and it would give me 2x squared minus x minus 6 at the end. Now, no matter what, our process is going to be identical to this. We're going to start out for 2x squared plus 7x plus 3. We're going to look for any sort of GCF. If I'm looking at 2, 7, and 3, there is no GCF. There's no common factor that I can divide out of those three things, and there's nothing for the x's, because this doesn't even have an x term, so there's nothing that I'd be able to remove there. No GCF. Next, same exact process. B on the top, a times c. A here is 2, b is 7, c is 3. On the top would go 7. On the bottom, 2 times 3 would be 6. And the same exact process now as any other one. Find two numbers that add to 7, multiply to 6. Numbers that multiply to 6 would be 6 and 1, because those two add to 7. Those are going to be my two factors, 6 and 1. Now, just like in the past, we will go through and, drop my food. Alright, what we'll go through and we'll do now is, from here, we're going to use our two binomials. We're going to write down our a value, which in this case was 2. So we're going to have 2x, 2x. Those are going to be the first terms in each binomial. And I'm going to use those two factors that I just came up with, 6 and 1. That would be step 3. Again, just rewriting these now in factors, with two binomials instead of having it in standard form. That's step 3. And the final step here would be to remove the GCF. So again, just like last time, I'm going to look at each binomial. Here I see that I have a GCF of 2, so I have some term that I can divide from both of these numbers within the binomial. Over here would be my GCF of 1. There's nothing that I could pull out from a 2 and a 1. This is going to give me x plus 3 times 2x plus 1 when I go through and I actually do that division. Now, this is always going to happen when I have an a value that's greater than 1. Because if I look at it here, I multiplied a times c. I multiplied 2 into this number. So what I have to end up going back and doing is I have to divide that 2 back out, or else my entire answer is going to be off by a factor of 2. Everything would be, every term a, b, and c would be multiplied by 2 instead of having the 2x squared plus 7x plus 3. If I went through and I FOILed this. If I went through x plus 3, 2x plus 1, and actually went through and FOILed all of that out, I would see I would actually get my 2x squared plus 7x plus 3. Because again, when we factor, we should be getting equivalent forms of the same thing. We're not adding anything in, and we're not taking anything away, but instead we're just writing something in a different format. Okay, last but not least, if I take a look at this example, we have 3x squared plus 17x plus 10. Same exact process again. I'm going to look for GCFs first. Amongst these terms, there is none. There's nothing that some term that goes into 3, 17, and 10, and they don't all share an x, so there's nothing that I'd be able to remove. Okay, looking here now, same exact approach. B on the top would be 17, a times c would be 30. And what this means, we have an a value of 3, and since I multiplied a times c down here, I'm going to have to end up dividing some 3 out in the end. Now I'm looking for things that multiply to 30 and add to 17. You guys can use your multiplication tables for this. What it ends up coming out to be would be 15 and 2. They both add 17, multiply to 30. Now, same exact process. Write out the binomials, and how I do that would be 3x plus 15, because that was one of our factors, and then 3x plus 2. Looking at this, just like the last step of our last equation, when we have our the last step in our process, I should say, 3x plus 15 times 3x plus 2, I'm looking for the GCF. I'm looking to divide that out. So I'm looking at both of these numbers. Here, I would be able to divide a 3 from both of these terms. Looking at 3 and 2, their greatest common factor is 1, so I can pull that out. Here I would have x plus 5. Here I would have 3x plus 2. Okay, when I divide each of these terms by 3, I get x plus 5. When I divide each of these terms by 1, I get 3x plus 2. And again, that should make sense because I multiplied by 3 in the beginning. In this step, when I multiplied a times c, I did 3 times 10. So I'm just multiplying this last number by 3. So I'm going to have to end up going back in and removing that. I have to end up dividing that out somewhere to make sure that these two expressions are equivalent. I can't just multiply by 3 and call it a day. I have to end up dividing that back out to make sure that it's equivalent to this original expression. And that would be the factor form of 3x squared plus 17x plus 10. Okay, again, process is similar. Now all we have to do is we change in step 2 that the a times c, we're actually multiplying by some number a, and then we have to end up dividing that number back out in the end, just to make sure that the expression stays the same throughout, that we're not adding or taking anything away when we shouldn't be.